This is Mr. Beck Does Your Homework. This is physics homework number 8, question number 10. It says a fireman 50.6 meters away from a burning building directs a stream jet of water from a ground level fire hose at an angle of 41.7 degrees above the horizontal. If the speed of the stream as it leaves the hose is 42.3 meters per second, at what height will the stream of water strike the building? I'm looking for this height above the ground. The acceleration gravity is 9.8 meters per second. So I need a height. So let me just look right away at X world and Y world. 50.6 meters, that's how far the stream of water needs to go. So that is my displacement in the X world. This is horizontal, 50.6 meters. Y world, Y is what I'm looking for. So I'm just going to write Y equals question mark as a placeholder. I have 42.3 meters per second at an angle of 41.7 degrees. What can I do with that? Well, that is my 42.3 meters per second. By now, if you've gotten this far, you should know that I can always split that into a velocity in the Y world and a velocity in the X world. And this is going to be my initial velocity in the Y world. And my velocity in the X world stays constant, so it doesn't matter. So my velocity in the X world is going to be my total velocity times the cosine of theta. So this Vx is going to be my total velocity times the cosine of the angle. There you go. Total velocity times cosine of the angle. And my Y velocity is going to be my total velocity times the sine of the angle. So I'm going to put those in up here. So my velocity in the X world, initial, final, all the time velocity, is going to be my total velocity, which is 42.3 times the cosine of 41.7 degrees. And in the Y world, my initial velocity is going to be 42.3 times the sine of 41.7 degrees. So it's this sine that, and this one is this times the cosine of that. I also know in the X world, of course, my acceleration is 0. In the Y world, my acceleration is gravity is negative 9.8 meters per second squared. So displacement, initial velocity, acceleration. I'm looking for displacement. I need one more variable. Final velocity might be hard to come to. So maybe time is what we need. So we're going to look for time, but instead of worrying about time in the Y world, what if I got it in the X world where it's easy to get because I have a distance and a velocity? So horizontally, I know it moves 50.6 meters, and its horizontal velocity is going to be the result of this. So I know that x equals vt, distance is velocity times time, meters per second times seconds, so that gives me meters, so that's good. So if I want time, my time is going to be my distance divided by my velocity. It's going to be my 50.6 meters divided by my velocity, which was 42.3 cosine 41.7. That will give me my time. Once I have my time will move right here into the Y world, and now I've got my time. So with a time, an acceleration, an initial velocity, and looking for a height, that turns into my favorite equation, y equals v0t plus 1/2 my acceleration times time squared. And I know my initial velocity here. I know my time here, I just figured it out, plus 1/2 of acceleration, which is negative, make sure you enter it as negative, times time squared. This initial velocity times time is where it would be if it kept on this path and moved up and up and up, but this 1/2 gt squared is how much it falls off of that path. So this is going to be negative because g is negative. So this is positive, this will subtract from it, leaving you hopefully a positive answer at the end to give you your y. So make sure you enter gravity as negative so that this takes away a little bit from this.